In this video, we're just going to look at how to partition a line segment. Now, there's 3 methods in which you can do so. So one of which is using this long formula. You are not given this formula on any assessments or the Regents examination at the end of the year, so it is important to know how to use it and to memorize it on your own. But when you use this formula, the x1 is from the first coordinate, and so is the y1. The second coordinate will be x2, y2. The a term will be the first part of our proportion, and the b term will be the second part of that ratio. Okay? Once we know that, we're able just to plug right into this coordinate. So we're going to get -8 plus 3 over 3 plus 2 is 5. 2 subtract a -8. And for the y's, we're going to have -6 plus 3 over 5. 9 subtract a -6. Now we just want to go through and evaluate those pieces now that we've plugged in. So we're going to leave that -8 for a moment. It's going to be times 3/5. We're going to 2 subtract a -8 is 10. When we multiply 3/5 times 10, we end up with 6. And we're going to end up with -2 as our x-coordinate. Over for the y-coordinate, same idea. We'll have -6 plus 3/5. When I combine 9 minus a -6, it's a total of 15. 3/5 times 15 will get us 9. And when we combine like terms, we'll get -3. So our point P along this segment is at -2, 3. An additional way you could do that, if you're provided a graph, is to draw in a right triangle. So I'm going to go back and just say, like, if we had x we knew was at -8, -6. Y was at the point 2, 9. Just check that those are my values. Yep. And because x, p to py are in a 3:2 ratio, we're going to use the graph to help us here. So first, I'm going to plot -8 and -6. And 2, 9. I'm going to try to keep a straight line up. Oops. Try to make it a little bit nicer here. Bear with me, I don't have a straight edge. You have your straight edge though, so it should be okay. There we go. What we can do is use that as the hypotenuse of a right triangle. So I just want to draw in 2 legs to make this into a right triangle for us. Now, with those 2 legs, we know the total length of the change in y is 15, as well as the bottom's total length is 10. What we have to keep in mind is our goal from doing this is to break this up into 3:2 ratio, which is a total of 5. If I want to break something into 5 total pieces, I just want to divide nicely. And you could pick the bottom or the horizontal to do this with. So let's say we did 15 divided by 5. That means each broken piece should be 3 units away from each other. So 3 from y, 3 from that point. And I'm going to keep doing this. So now if I look, I've cut it into 5 equal pieces. I could have done that from the base, then it would have been 2 away each time. Now the only thing left here is we have to think, we wanted to find the spot that's 3 away from x and 2 away from y. So if I count 3 up from x, that's going to be point P is right here. And you'll know it's 2 away from y as well. And if we look on our graph, we have that point P is at -2, 3. That's exactly what we calculated in the first method, so we know we did it right. But this one, the only thing is it only works if you have a graph available. Final method, which is the method we use more often in class, is, again, I'm just going to rewrite my points here. We know x is at -8, -6. Y is at 2, 9. and our ratio xp to py is equal to 3 to 2. So that being said, in case I don't have a graph, and in case it's hard for me to remember a long formula like that, I like to try to make my own picture. And it doesn't have to be drawn to scale. Anything that we make on our own will never lose us points. And I'm going to call it x and y, which I know my points are at -8, -6, and at 2, 9. I know this isn't an accurate picture, but it's just enough for what we need. I first want to think that I'm breaking this up into a total of 5 pieces. So I'm just going to draw in 5 breaks here. They don't have to be perfect, but I know P is going to lie here because it's 3 away from X and it's 2 away from Y. So I'm looking for the points that could fill that piece. Now I have to find the X coordinate as well as the Y coordinate. So I'm going to start with X. I'm going to figure out how far apart this whole line segment is. So I'm going to take the X values to subtract a -8, and that's 10 total units. That 10 is going to be broken up into 5 equal pieces. So since we're breaking it up into 5 equal pieces, that operation is division. And I'm going to get 2. Now, what I should recognize about that 2 is that it's going to change by 2 each time the X coordinate. So 2, 2, 2, that's a total of 6. Okay, it's changing 3 times. So I get 6. And to finish that off, I'm adding that to where we started in the first place. So when I look here, I started with that -8. So -8 plus 6 is equal to a -2, which is so far good because that's what we got for all the other ones as well. Now I have to do it for the Y coordinate as well. So I'm going to do a very similar situation here. I'm going to take the Y's and subtract them. So I'm going to have 9 subtracted -6 to get 15. That 15 total units is still being broken up by 5 because each of our pieces, there's 5 total equal places, which gets us 3 each time. Now, I'm changing the Y's by 3 each time, so it's changing 3, 3, and 3 for a total of 9. It's like 3 times 3 equals 9. And when I put this all together here, I'm going to add it to the first Y, so -6 plus 9, and that equals 3. And yet again, we'll find that our coordinate answer here, P, is at -2, 3. So each of these answers got us the same thing because they're all equivalent methods. So if I go back to the beginning, if you're good with a formula and memorizing one, you can definitely use method 1. If they provide a graph and you like this visual aspect, then go with method 2. And if you're like me who likes to draw their own picture and try to make the visual happen and understand where this is all coming from, we can go with method 3. So one example that I wanted to point out to us, it's a little different than ones we've dealt with recently, is we have point Q that's on MN such that it partitions the segment by 2/5. So this is the first time we haven't talked about a ratio. So remember, A over A plus B is 2/5. So we know A, that first part of the ratio, is 2. The second part of the ratio is going to be 3. So it's just a different way to word this problem. Okay, so we're splitting that up into a 2 to 3 ratio. Or you could use that as A over A plus B in the formula. I'm going to do the wet method that I like to draw my picture here. So I have the coordinates of M and N. So M, N, 8, -5, and N is 8. Oops, sorry. M is 3, 5. And N is 8, -5. Sorry about that. And we're actually splitting it up by a total of 5, not of 7, because the bottom of that fraction is going to be a total of 5. And 2 is the top, so our point Q is 2 away from M, but 3 away from N. Okay. And so we're going to find that by doing the same thing we did. I'm going to take my x's. So we know here that we have 8 subtract a negative 3 equals 11. Whoops, realize it's not a negative 3. We had a positive 3 here, so I'm just going to go back and fix that for us. So it's actually 8 subtract a 3 equals 5. We're breaking up into 5 equal parts, so 5 divided by 5 is 1. That means it's changing by 1 each time, so 1 and 1, so 3 plus 1 is 1. So I know it's going to be, the x-coordinate is going to be at 5. So I could cross off 3 and 4 so far. We're going to do the same thing for y now. Negative 5 subtract 5 is equal to negative 10. Negative 10 divided by 5 is negative 2. So it's changing by negative 2 each time. So negative 2 to 3 is going to make 1, and a negative 2, so 5. So it's a total of, we're going to have negative 4 total onto the 5. So 5 plus a negative 4 equals a positive 1. So it's going to be choice 1 here. Okay. So remember, you can do any of these 3 methods that you so choose to do. I personally like method 3. If you like 1 or 2 better, then that is